In this tutorial video today, I would like to speak about flow measurements and application notes. So I will demonstrate the working principles, the advantages and disadvantages of almost 90% of Flowmeter devices. So if you need any additional technical information, you can review my previous videos about Flowmeter devices. Or you can contact me and send me your question and I will get back to you as soon as possible. Now let's go.
Tutorial contain flow measurement categories, general application notes, flow meters with fixed wetted parts, flow meters with moving wetted parts, obstruction-less flow meters, flow meters with sensors mounted externally, comparison table. Flow measurement categories. Flow meters operate according to many different principles of measurements. They can be classified into 4 categories. Flow meters with wetted moving parts such as positive displacement, turbine, and variable area. Flow meters with wetted fixed parts such as vortex, differential pressure, target and thermal. Obstruction-less flow meters such as Coriolis, magnetic and ultrasonic. Flow meters with sensors mounted externally such as clamp-on ultrasonic and were flow measurements. Flow meters can also be classified according to 4 types. Volumetric, such as positive displacement meters. They measure volume directly. Velocity, such as magnetic, ultrasonic meter. Total flow is determined by multiplying the velocity by the area through which the fluid flows. Inferential, such differential pressure, dP, target, and variable area meters. The flow is inferred by some other physical property, such as differential pressure, and then experimentally correlated to flow. Mass, such as Coriolis mass flow meters. These devices measure mass directly. Flow can be defined as a volume of fluid passing a given point per unit of time in a pipe. This can be expressed by Q equals A multiplied by V, where A is the cross-sectional area of the pipe. V is the average fluid velocity. Mass flow may then be defined as flow multiplied by density. Flow measurement, general application notes. Depending on which type is selected, many parameters need to be considered when applying flow meters. Ignoring such parameters may result in a measurement with a high error or one with a short lifespan. Flow measurement also requires a closer look at, depending on the type of fluid and whether it is dirty or clean. The flow profile. The pressure loss allowed, piping considerations, straight pipe run requirement or the use of straighteners, the line size. Fluid. The type of fluid may limit the type of device available. For examples, on vortex meters and differential pressure devices, liquid, gas, and steam can be measured. On magnetic meter, severe service for conductive fluids can be measured, where orifice plates or vortex shears are not suitable. On most turbine meter, steam cannot be measured. Flow profile. Flow profiles can be classified into 3 types: laminar, turbulent and transitional, and these can be determined in a relationship called the Reynolds number, RD. RD equals diameter of pipe multiplied by average flow velocity multiplied by density of fluid, divided by absolute viscosity of fluid. The flow considered laminar if RD less than 2000. If RD reaches 4000, it starts becoming turbulent. The range between 4000 and 7000, where the flow is becoming turbulent, is an unstable and complex condition that is affected by many parameters, such whether velocity is increasing or decreasing. Piping. Flowmeter performance is normally stated based on ideal reference conditions. Variances in inside diameter of piping and in upstream and downstream runs including restrictions, valves, solid buildup, and misaligned gasket affect flowmeter performance. Therefore, no flow measuring loops. The control valve is typically located downstream of the measuring element. This is to avoid the disturbances to the flow stream that result from the throttling action of the valve which affect the accuracy of the measuring element. Line size. Not all measuring devices cover all line. For example, the maximum size of most Vortex meter is generally 8 inches. Therefore, the question is whether the selected flow device can handle the line size and required flow. Flow meters with fixed wetted parts. Vortex Flowmeter. Vortex flow meters can measure liquid, gas or steam and use the principle of vortex shedding. Vortex shedding occurs when an obstruction is placed in the flowing stream. The obstruction is referred to as a bluff body and causes the formation of swirls, called vortices, downstream from the body. Differential pressure changes occur as the vortices are formed and shed. This pressure variation is used to actuate the sealed sensor at a frequency proportional to the vortex shedding. Advantages. Suitable for liquid, gas or steam. Used with non-conductive fluids. No moving parts, low maintenance. Sensors available to measure both gas and liquid. Not affected by viscosity, density, pressure or temperature. Low installation cost. Good accuracy. Linear response. Disadvantages. Unidirectional measurement only. Clean fluids only. Not suitable with partial phase change. Not suitable for viscous liquids. Large unrecoverable pressure drop. Straight pipe runs required for installation. Differential pressure flow meters, primary elements, such as venturi tube. An orifice plate. Flow nozzle. In addition to pitot tube. Differential pressure flow meters, primary element orifice plate. The orifice plate flow detector is the simplest of the flow path restrictions used in flow detection, as well as the most economical. Orifice plates are flat plates 1/16 to 1/4 inch thick. They are normally mounted between a pair of flanges and are installed in a straight run of smooth pipe to avoid disturbance of flow patterns from fittings and valves. Advantages. Simple construction. Inexpensive. Easily fitted between flanges. No moving parts. Large range of sizes and opening ratios. Suitable for most gases and liquids. Well understood and proven. Price does not increase dramatically with size. Disadvantages. Inaccuracy, typically 1%. Accuracy is affected by density, pressure and viscosity. Physical damage affects measurement accuracy. Cause some unrecoverable pressure loss. Viscosity limits measuring range. Require straight pipe runs to ensure accuracy is maintained. Flow meters with moving wetted parts. Variable area flow meter. Variable area flow meters work with low viscous liquids at high velocities. The principle of operation is that the flow stream displaces a float placed in the stream. The rate of flow is related to the area produced by forcing the float up or down, and varying the area. It is because of the low viscosity and high velocity that the frictional resistance of the flow is negligible compared to the resistance of the obstruction, float, placed in the flow stream. Advantages. Inexpensive. Wide range of applications. Very basic operation. Easy installation and simple to replace. Disadvantages. Limited accuracy. Subject to density, viscosity, and temperature. Fluid must be clean, no solids content. Erosion of device, wear and tear. Can be expensive for large diameters. Operate in vertical position only. Positive displacement, rotary piston. Positive displacement meters measure flow rate by repeatedly passing a known quantity of fluid from the high to low pressure side of the device in a pipe. The number of times the known quantity is passed gives information about the totalized flow. The rate at which it is passed is the volumetric flow rate. Advantages. Reasonable accuracy of 0.1%. Suitable for high temperature service, up to 180 degrees. Pressures up to 7 megapascal. Disadvantages. Suitable for clean liquids only. Pressure drop issues. Higher maintenance costs. Low flow rates. Turbine flowmeter. Turbine meters have rotor-mounted blades that rotate when a fluid pushes against them. They work on the reverse concept to a propeller system. Whereas in a propeller system, the propeller drives the flow, in this case the flow drives and rotates the propeller. Since it is no longer propelling the fluid, it is now called a turbine. Advantages. Reasonable accuracy of 0.1%. High accuracy, repeatability and rangeability for a defined viscosity and measuring range. Temperature range of fluid measurement, -220 degrees to +350 degrees. Very high pressure capability, 641 bar. Measurement of non-conductive liquids. Capability of heating measuring device. Suitable for very low flow rates. Disadvantages. Not suitable for high viscous fluids. Viscosity must be known. 10 diameter upstream and 5 diameter downstream of straight pipe is required. Not effective with swirling fluids. Only suitable for clean liquids and gases. Pipe system must not vibrate. Obstruction-less flow meters. Coriolis flowmeter. The force is applied to oscillate the flow pipes, and the Coriolis effect is the principle used to determine the acceleration due to the torque, the amount of twisting. Sensors are used to measure the amount of twist in the flow tubes within the meter as a result of the flow tube vibration and deflection due to the mass flow. The amount of twist measured is proportional to the mass flow rate and is measured by magnetic sensors mounted on the tubes. Advantages. Direct, inline mass flow measurement. Independent of temperature, pressure, density, conductivity and viscosity. Sensor capable of transmitting mass flow, density and temperature. High density capability. Conductivity independent. Suitable for hydrocarbon measurements. Suitable for density measurement. Disadvantages. Expensive. Affected by vibration. Installation costs. Adjustment of 0 point. Electromagnetic flowmeter. Electromagnetic flow meters, also known as mag meters, use Faraday's law of electromagnetic induction to sense the velocity of fluid flow. Faraday's law states that moving a conductive material at right angles through a magnetic field induces a voltage proportional to the velocity of the conductive material. The conductive material in the case of a mag meter is the conductive fluid. Advantages. No restrictions to flow. No pressure loss. No moving parts. Good resistance to erosion. Independent of viscosity, density, pressure and turbulence. Good accuracy. Bidirectional. Large range of flow rates and diameters. Disadvantages. Expensive. Most require a full pipeline. Limited to conductive liquids. Ultrasonic Flowmeter, Doppler effect. The Doppler effect device relies on objects with varying density in the flow stream to return the ultrasonic energy. With the Doppler effect meter, a beam of ultrasonic energy is transmitted diagonally through the pipe. Portions of this ultrasonic energy are reflected back from particles in the stream of varying density. Since the objects are moving, the reflected ultrasonic energy has a different frequency. The amount of difference between the original and returned signals is proportional to the flow velocity. Advantages. Suitable for large diameter pipes. No obstructions, no pressure loss. No moving parts, long operating life. Fast response. Installed on existing installations. Not affected by fluid properties. Disadvantages. Accuracy is dependent on flow profile. Fluid must be acoustically transparent. Errors caused by buildup in pipe. Only possible in limited applications. Expensive. Pipeline must be full. Ultrasonic Flowmeter, Transit Time Technology. The transit time flowmeter device sends pulses of ultrasonic energy diagonally across the pipe. The transit time is measured from when the transmitter sends the pulse to when the receiver detects the pulse. Each location contains a transmitter and receiver. The pulses are sent alternatively upstream and downstream, and the velocity of the flow is calculated from the time difference between the two directions. Advantages. Suitable for large diameter pipes. No obstructions, no pressure loss. No moving parts, long operating life. Fast response. Installed on existing installations. Not affected by fluid properties. Disadvantages. Accuracy is dependent on flow profile. Fluid must be acoustically transparent. Errors caused by buildup in pipe. Only possible in limited applications. Expensive. Pipeline must be full. Flow meters with sensors mounted externally. Ultrasonic Flowmeter, Clamp-on. Clamp-on ultrasonic flow meters can be delivered for both Doppler and transit time. Advantages. Non-invasive flow monitoring. Measurement of non-conductive fluids. Easily installed clamp-on sensors with no interruption to flow. Wide range of pipe materials and sizes, 12.7 to 7,600 mm. Process temperatures from -40 degrees Celsius to 200 degrees Celsius. Integrated wall thickness measurement. Disadvantages. Accuracy is dependent on flow profile. Here we have a comparison table of almost all flowmeter devices. This will help you to select the appropriate flowmeter for your application. Reference. If you like this video, please subscribe this channel and press bell icon to get notification of new videos. Thank you so much for watching and have a nice day.